Hello, welcome to Liquid Brain. So this is a part 2 video of data manipulations and data transformation using dplyr in R and R Studio. So today we're going to talk about a range. So we have talked about filter in the first video. If you have not watched that, I strongly encourage you to go there and try to at least finish the first 5 minutes on how the data is structured, where is the data coming from, and how does the data look like before we go here. Otherwise it's going to be slightly confusing. So a range function is fairly straightforward. Is how do you want the data to be arranged alphabetically, numerically, and so on. So in this case, let's look at our first example. So flights, year, month data, you can see over here. The first one is always the name of the data frame, and the one subsequently is the name of the column. So in this case, we want to arrange the data frame in the flight data frame based on the year, month, and the day. So if we run this chunk, you can see that it's arranged from the 1st of January, obviously, and it goes, let's go to 100, so until the second day, because the output over here only show the first 1,000 row, and it's not enough to show you everything else. But it will be arranged based on the year, and then based on the month, and then based on the same day. So subsequently, based on the, what is that called, ascending order. Yeah, we will show you how to do the other way later. Okay, so this is the way to do actually descending order. So if you want it to be arranged by biggest to smallest, you just add a descending descending function outside the variable that you want to. So if you run this, you realize that departure delay is ranged from the largest and slowly down to the smallest. So you can go here, departure delay is 200, you can go 97, it's about 272, go to the first one. So you can see this slowly going down, and this is how you do the descending array in this thing. Okay, so that's basically it. So let's go to the exercise. So as the previous video, you can download the exercise in the video description below, which will bring you to a website, and there you'll be able to find this with or without the answers. The thing is that this is actually run in R Markdown, so if you actually want to copy paste the function, remember to use the R notebook to create an empty file and then copy paste the content over from the Google Doc. Okay, so let's look at our 4 questions below. So the first one is, how could you use arrange to sort all missing value from the start? Okay, so in the arrange function itself, it actually doesn't know the difference between NA and value. So what they do is that they'll put all the NA in the bottom. So they'll just pretend that doesn't exist and arrange everything else, and whatever NA, they'll put it in the back. So this is what happened. So in order for you to actually run the NA in the top, what we do is use a function called is.na. So in this case, is.na will be converting the departure time, rather than in numerical value, we'll be converting it to true and false. So since you are actually descending down in true and false, which is 1 and 0, you actually arrange 0 and then 1. 1 and then 0. So we want the false first, we want the true first and then the false. Okay, so in this case, it will arrange the departure time based on the NA, and then you will be the departure delay, arrange the time delay, and then so on. So it will arrange like this based on the code over here. Okay, so you can see all the NA are now all on the top. So just to make sure that I understand, you pipe this into is.na, which convert it into true and false. So everything true become a 1, everything false become a 0. And then instead of actually arranging based on the raw number itself, you're now arranging based on 1 and 0. Since we're on descending, 1 will go first, 0 will go back. So everything it is NA will go top, and everything that's not NA will go down in the bottom. Yes, okay, so that basically it. Okay, the second one is sort flight to find the most delayed flight and find the flight that left the earliest. So this is fairly straightforward, a lot easier than the one just now. So with the most delayed flight, okay, we just sort it based on the departure delay, but because it's the most delayed one, we want it to sort descendingly. Yeah, we want it to sort descending, means largest on top, smallest on the bottom. So this is very straightforward. We already demonstrated in the example up above. Okay, so find the flight that left earliest. same thing. So we can actually just arrange based on the hour and the minute. So actually this is in the back, so hour and a minute. So this is 1 o'clock, so 1 a.m. in the morning, and then everything else is about 5 a.m. in the morning. So that will be able to tell us that the flight is the earliest. So I'm not too sure that 1 o'clock in the morning is the one today, because it's actually usually the delayed one from the day before. So yeah, it's more of a classification problem already, but the code works like that. Okay, sort the flight to find the fastest flight speed. Okay, so in this case, we are doing a little bit of arithmetic calculations there. So we do have the distance of the flight, and we do have the air time. So if you're not familiar with air time, is how long does the plane stays in the air. Okay, so in order to calculate the fastest velocity, or in this case, just speed, or velocity, we just do distance divided by time, which gives us the speed. And we arrange them based on smallest to biggest. So actually we need to find the fastest, so we need to actually do this. So this will actually arrange based on the biggest number to the smallest number, and we can run it. So we can actually see that this one will be the fastest, because they have they flew 760 kilometers in 65. So it could be miles, I don't know, they didn't specify the parameter over here. But if you divide that manually, you'll be able to find which they are in fact a lot faster than, let's say, so this one is actually about more than 10 miles an hour. So you go to 100, it's a lot less than 10 miles an hour. So the arrangement makes sense over here. So we'll tell you how to do the other new column later, where we actually calculate and display that. Okay, let's go to the last question. So which flight traveled the furthest, or which flight traveled the shortest? So fairly straightforward, just arrange it based on distance, where the distance will be here. So this is the shortest, which is 7 miles and 80 miles, 80 miles, 80 miles. And if you run it the same way but in reverse, you can actually see that the distance is about 5,000 kilometers, and this is 5,000 kilometers, and so on and so forth. So that's basically finish up our video on the range. Fairly straightforward. Just put your flight and then arrange, and just put in the name of the column in the back. That's it basically. Okay, so thanks for watching. We'll go into our next functions, which is the select function, in the next video, and we'll see you in a few seconds. Bye.